My work is in string theory. In fact, I'm the co-founder of string field theory, which allows you to summarize all the laws of string theory into an equation about 1 inch long. Well, that's my equation. I helped to write that with Professor Kikawa of Japan. And in fact, you can even get a t-shirt which has my equation on it. However, my equation is not the final word. Because first of all, there are 5 different string theories. So there are 5 different 1 inch equations for each of the different string theories. And now we have something called M theory, a theory of membranes vibrating in 11 dimensions. And we are clueless, absolutely clueless about getting that 1 inch equation that will allow us to understand M theory, membrane theory. So we are in some sense going back to square one in terms of the mathematics. But in terms of the theory itself, we hope to match string theory with the results of the Large Hadron Collider. First of all, dark matter. We now realize that most of the matter in the universe is dark, invisible matter. If I have dark matter in my hand right now, it would be invisible. In fact, it would literally dissolve its way right through my fingers, go right to the center of the earth, or go right to China, back to the center of the earth, and back up into my hand. And then it would simply oscillate between China and my hand forever. That's dark matter. And you know, it means that every single chemistry book and science book on Earth is wrong. Every book of science says that the universe is mainly made out of atoms. Hydrogen, helium, going up to uranium. Wrong. We now realize that most of the matter in the universe is dark matter. And most of the energy of the universe is dark energy, an invisible energy that permeates the vacuum of space and time. In fact, 73% of the energy of the universe is dark energy. And we're clueless about what is the nature of dark energy. 23% of the matter energy of the universe is dark matter. And we hope to create dark matter with the Large Hadron Collider. Well, where do we fit into this? Stars made out of hydrogen and helium make up 4% of the universe. But what about us? What about oxygen, nitrogen, carbon? What about us? We make 0.03% of the universe. Let me repeat that again. The atoms that are familiar to us, the higher elements, make up 0.03% of the universe. We are the oddballs. We are the exception. Most of the universe is made out of dark energy and dark matter, and we hope to create dark matter with the Large Hadron Collider. The leading theory of dark matter is that it is caused by sparticles. Sparticles are superparticles, higher vibrations of the string. So we represent perhaps the lowest octave of the string. Everything you see around us is nothing but the lowest vibration of the string. But the Large Hadron Collider would be powerful enough to excite the next set of vibrations, superparticles, sparticles, that may make up dark matter. But there's another theory about the nature of dark matter. If our universe coexists with a parallel universe, and there is a galaxy in this parallel universe, it would be invisible, because light would move behind, underneath this parallel galaxy. But gravity seeps between galaxies. Therefore, you would feel its gravitational effects, but it would be invisible. Now, what is invisible but has gravity? Dark matter. So ironically, maybe we have already discovered dark matter. Already, dark matter exists in a parallel universe whose gravity we detect in our universe. So the Large Hadron Collider outside Geneva, Switzerland, may finally answer the question, what is dark matter? We know it holds the galaxies together, but what is dark matter? I should also point out that there's a little bit of a sad story with regards to dark matter. Dark matter was actually postulated by a woman, Vera Rubin, back in the 1960s. Our Milky Way galaxy rotates so fast that by rights, by Newtonian mechanics, it should fly apart. Well, Vera Rubin's results were considered ridiculous. How can our galaxy spin so fast that it has to fly apart? She said, well, maybe there's matter out there holding it together. People laughed and pretty much ignored her work. Not anymore. So there is a dark secret in our field of physics, and that is that women scientists are sometimes not treated as equals. The most famous case is that of Jocelyn Bell. Back in the 1960s, she was a lowly female graduate student who saw a star blink at her through a telescope. Well, she carefully logged the blinking of that star day after day, night after night, week after week, and then she made the biggest mistake of her professional life. She told her thesis advisor. He came over, took one look, and said, "Oh, hey." Well, when it was time to write up the paper, whose name came first? Jocelyn Bell, the one who made the discovery, who on very cold nights would log this tiny star blinking at her, or the famous scientist? Well, his name came first. When it was time to give talks around the world, who gave the talks? Her or the scientist? He gave the talks. And when it was time to win the Nobel Prize in Physics for the discovery of the pulsar, who won the Nobel Prize? He did. Now, what's the lesson here? The lesson here is if you ever make an astounding discovery, tell me first. I mean, I'm a generous man. I'll give you a nice footnote, a subway token perhaps, to reward you for making this fantastic discovery. But hey, we big-name scientists, our name comes first.